Hello, and welcome to Learning Outcome 1, Understanding the Principles of Computer Programming. In today's session, we will explore the question, what makes computer programming essential in today's world? This video introduces the fundamental principles of computer programming, covering key concepts such as object-oriented programming, algorithmic logic, and problem-solving techniques. You will discover how these principles underpin software development, drive technological innovation, and shape the digital solutions that power modern life. Programming involves instructing a computer to perform tasks through a language like Python or Java. The process begins with identifying a problem and creating an algorithm. This algorithm is a sequence of steps that the computer follows to find a solution. Programming languages provide the syntax and semantics to write these instructions. Mastering programming involves understanding both the language and the logic behind it. Every programming language has its own syntax and semantics. Syntax refers to the rules for writing code, while semantics define the meaning of the statements. For example, Python requires specific punctuation to execute commands. Errors in syntax can cause programs to fail. Understanding these rules is crucial for writing effective code. Algorithms are step-by-step procedures for solving problems. Good programming starts with algorithmic thinking, which involves breaking down problems logically. Control flow, like loops and conditionals, guides the program's execution. For instance, finding the largest of three numbers involves comparing them sequentially. This logical approach ensures efficient problem solving. Control structures dictate the flow of a program. Sequence, selection, and iteration are the main types. Sequence runs instructions in order, while selection makes decisions using if or else. Iteration repeats actions using loops like for or while. These structures allow for complex operations and decision-making in code. Data types define the kind of data stored in variables. Common types include integers, floats, strings, and booleans. Variables act as containers for these values, making code flexible. For example, a variable can store a user's name or age. Understanding data types is key to manipulating data effectively. Functions break programs into reusable blocks of code. They enhance readability and simplify debugging. Modularity allows functions to operate independently, improving maintenance. For instance, a function can greet users by name with minimal code. This modular approach streamlines complex programming tasks. Debugging involves identifying and fixing errors in code. Errors can be syntax, logic, or runtime related. Testing ensures programs behave as expected in various scenarios. Regular testing reduces failures after release. This process is vital for maintaining reliable software. Well-documented code is easier to understand and modify. Comments and consistent formatting aid in readability. This practice supports collaboration and future updates. For example, comments explain the purpose of complex calculations. Maintainability ensures long-term code usability. Programming solves complex problems efficiently. It automates tasks, saving time and reducing errors. In healthcare, it predicts diseases using patient data. In business, it aids in financial forecasting and analytics. Programming transforms processes across various sectors. Programming principles guide software design and maintenance. Abstraction simplifies complex problems by focusing on essentials. Modularity divides programs into independent sections. Reusability allows code to be used across projects. These principles ensure efficient and reliable programming. Abstraction focuses on essential details, hiding complexity. It breaks systems into manageable parts. Modularity divides programs into modules, each with a specific task. This approach simplifies testing and updates. Together, they enhance productivity and clarity. Reusability means writing code for multiple uses. It reduces errors and saves time. Maintainability focuses on easy code updates and fixes. Clear variable names and comments aid in understanding. These principles support long-term software growth. KS stands for Keep It Simple, Stupid. It encourages simple, readable code. Dry means don't repeat yourself, avoiding code duplication. These principles prevent errors and simplify maintenance. They lead to efficient and manageable code bases. Coupling measures module dependency. Low coupling means modules operate independently. Cohesion refers to how related functions within a module are. High cohesion focuses on a single task, improving clarity. Together, they enhance code flexibility and maintainability. The open/closed principle states software should be open for extension but closed for modification. It allows new features without altering existing code. This reduces the risk of introducing errors during updates. It encourages flexibility and robust design. This principle supports sustainable software development. Encapsulation keeps data and methods together, restricting access. It protects data integrity and prevents interference. For example, a banking app may keep balance variables private. Changes can only occur through defined methods. This ensures data security and reliability. Testing verifies program functionality under different conditions. Debugging finds and fixes code errors. Regular testing ensures reliable software. It reduces costly failures after release. This process is crucial for quality assurance. Programming history spans nearly 2 centuries. From Babbage's analytical engine to modern languages, it has evolved significantly. Key milestones include machine-readable data and high-level languages. These developments shaped programming practices. The journey reflects continuous innovation in computing. Early programming used low-level languages like machine code. High-level languages emerged for easier coding. Fortran and COBOL were among the first. They made programming more accessible and efficient. This evolution marked a major leap in computing. Improved conclusion and conclusion. The principles of computer programming form the foundation for creating reliable and effective software solutions. From abstraction to encapsulation, each principle plays a vital role in ensuring code is efficient, maintainable, and adaptable. Understanding these core concepts is essential for programmers seeking to develop high-quality applications and contribute to ongoing technological innovation. Thank you for watching this video. If you have any questions, please feel free to send a message via WhatsApp. Thank you for your attention, and see you soon.